Hello student, today I am going to discuss again question answer for upcoming JEE and Neet, and it is very useful for the revision because different types of questions when you will start solving it will boost up your confidence. Question answer discussions, we discussed several questions. Today also we will discuss several model questions for upcoming JEE and Neet, which will boost up your confidence as well as it will revise your different types of concept based on the NCERT. As far as JEE and Neet is concerned, NCERT is the key, line to line and word by word. From there, question used to come. So that's why NCERT concepts are very much important for JEE and Neet. So now, as our subject is chemistry, so then chemistry will be a very scoring subject for each and everybody. Even low achiever to the high achiever, chemistry will be always helpful to bring the main score. So that's why try to look into the chemistry in a proper way. So now the today's fast questions, question number 51, which is given in that questions, when the 2-bromo-butane react with alcoholic KOH, the reaction is called. They're giving a one reactions based on organic chemistry, and this is a part of a alkyl halide chapter because it's a reaction of alkyl halide. There are two perspective is there in this question. This question can be connected to a two organic chapter because on the reactions it will produce the alkene. So then that perspective I can say it's a preparations of alkene as well as it's a reactions of alkyl halide. So that's why this question is connecting the two chapter. One is alkene, that means hydrocarbon chapter is there, alkane, alkene, alkyne is there, and also alkyl halide second year topic is there, organic chemistry. And weightage as far as JEE is concerned, as far as Neet is concerned, as far as JEE Advanced is concerned, the weightage of this alkyl halide chapter is very high. Is it clear? Minimum 1 to 2 questions used to come almost all the exam. So it's the organic questions which is connecting your hydrocarbon, or it is related to the alkyl halide chapters. So now in these questions, if you look at what is they are giving and what is forming, if you look at very properly what is they are giving and what is happening, if you look at properly, then you look at what we are going to explain. 2-bromobutane. Let us look at what is 2-bromobutane. CH3, CH2, CHBr and CH2, CH3. This is your 2-bromobutane there. Now you look at this is treated with alcoholic KOH. Alcoholic KOH is a strong base. So now whenever they are treated with a alcoholic KOH, this is a alcoholic KOH. Alcoholic KOH means elimination reaction. Elimination reaction. Aqueous KOH means substitutions reaction. Always you have to keep in mind alcoholic KOH means which reaction? Elimination reaction. Aqueous, same species, if I treated with a aqueous KOH, then immediately it should come into your mind. Suppose the species is 2-bromobutane. If I am giving aqueous KOH, then it's a which reaction? Substitutions reaction. Substitution. Which substitution? Nucleophilic substitution reaction. So alcoholic KOH means same 2-bromo. This is nothing but your numbering you look at. I hope IUPAC name you know very well. This is a 2-bromobutane. Yes or no? This is a 2-bromobutane. In 2-bromobutane, we are giving a alcoholic KOH. Then the reaction is proceed which pathway? Alcoholic KOH means elimination pathway. Whereas aqueous KOH means which pathway, my dear? Aqueous KOH means substitution pathway. but here they are giving alcoholic KOH. Definitely reaction is proceed via elimination pathway. And in elimination mechanism, there are three mechanisms there. I hope you know that one. What is that one? E1 mechanism, E2 mechanism, as well as U1CB mechanism. There are three mechanisms there. E1 mechanism is leaving group first departed, carbocation formed, and then the base will abstract the proton and alkene used to form. E2 mechanism, the abstraction of proton and departure of leaving group both is happening in a concerted pathway. Whereas E1CV, abstraction is proton will occur first whenever we have a very bad leaving group like OH minus, like A minus. Then first abstraction of proton and conjugate base formations will be there, and then only leaving group departure will be there. But E2 leaving group departure and abstraction of proton both will happen in a simultaneous manner, whereas in E1 mechanism, departure of leaving group will be occur faster step, and carbocation will be formed. And then always you have to check for any reaction is proceed via carbocation pathway, you have to check any rearrangement is possible or not. What are the possible way? Either by hydride shift, either by methyl shift, either by phenyl shift, either by ring expansion, either by ring contraction, or by both. I have to check all those points. Then only final product means alkene will form. This is the basic idea. Now, here the alcoholic KOH is there and my leaving group is a bromine. Whenever I have a strong base as well as leaving group or good leaving group, then reaction is proceed via E2 pathway. But if there is a good leaving group like a bromine is there, but the base is weaker base like H2O, like MUH, reaction will proceed via E1 pathway. So now here reaction is proceed via E2 pathway. How it will goes? There are two possibilities is there, two types of alkene. What is that, my dear? You look at, there are two possibilities. What is that? Here this proton and here you have a Br and here we have a situation is like this. Now there are two possibility. That means whenever alcoholic KOH is given, then OH minus will abstract this proton and this will shift over here, and this is your leaving group and this is your proton. With respect to leaving group, this is a alpha carbon, this is a beta carbon, and this is a beta hydrogen. Now the eliminations reaction, most important idea is this leaving group and beta hydrogen, they should be in a anti-periplanar conformation. So that's why if you look at these leaving group and these beta hydrogen, they should be anti-periplanar. They should be in a same plane, but they should be anti to each other. And that's why that is the criteria, stereochemical criteria for the reactions. So now that's why if you look at this type of product forming means here we will get this product CH2 double bond CH and then CH2 CH3. This is nothing but your but-1-ene, one possibility, but-1-ene. Now, if this proton abstraction is there, like other side proton abstraction is there, like this, and this bond will come over here and this will go. And then you will get from here CH3, CH double bond, CH, CH3. That is nothing but a but-2-ene. Now, if you look at this is a but-2-ene and this is a but-1-ene. And now but-2-ene is nothing but this is a less substituted alkene, this is a more substituted alkene. With respect to double bond, more alpha hydrogen. If you look at with respect to this double bond, this is a alpha, this is a alpha, 6 alpha hydrogen. With respect to this double bond, here only alpha, there are 2 alpha hydrogen. If alpha hydrogen more, hyperconjugation will be more, exchange will be more, stability will be more. So that's why more substituted double bond means with respect to double bond, more alpha hydrogen, more hyperconjugation effect, more exchange, and that will be more stable as far as product is concerned. That means there are 2 isomeric product possibilities there. One is but-1-ene, another possibility but-2-ene. So that's why this reaction first of all is proceed via E2 pathway, concerted. Abstraction of beta hydrogen as well as departure of leaving group both will occur simultaneous manner. This side, this is your beta carbon, from this side leaving group alpha carbon, this is also your beta carbon. So abstraction of beta hydrogen and departure of leaving group both will occur simultaneous pathway. Reason is the base is strong and good leaving group. Whenever your leaving group is chlorine, bromine, iodine, then your more substituted alkene is nothing but a Sedgwick product will be the major product. This more substituted alkene is called as a Sedgwick product. This is called as a Sedgwick product. Whereas least substituted alkene is called as a Hofmann product. Hofmann product. And ultimately, if you look at generally whatever mechanism E1 or E2, if your leaving group is bromine, chlorine, iodine, least substituted alkene will be a minor product and most substituted alkene will be the major product. But here the mechanistic path is a E2, there is no issue in it. So that's why there are two important criteria I told that what is that your leaving group and beta hydrogen, they should be anti-periplanar conformation, and in this situation these will be your major product. Major product we used to call it as a Ma, minor product we used to call it as a Me. So then but1ene will be Me, whereas but2ene will be your Ma, major product. So now one of the isomeric product is dominant over the other in eliminations reaction which is happening over here. So that's why this reaction is stereospecific as well as stereoselective. That means what is specific? Speciality in the reactant. What is selective? Speciality in the product. That means reactant has to orient in such a way, then only reaction will occur. What is that condition? That beta hydrogen and leaving group, they should be anti-periplanar conformations. As well as, that's why it's a stereo-specific reaction. Whereas that the one of the isomeric product is a dominant over the other, that's why it's a stereoselective. Even we called as a regioselective. In one region this reaction is happening in a major percentage, that's why it is also called as a regioselective. And from the mechanism we understood ultimately what is happening, my dear, hydrogen and bromine means halogen, they are going out and double bond is creating. That's why it's a which type of reaction? Dehydrohalogenation reaction. This is not a halogenation. That means halogen addition is not there. Chlorination means chlorine addition. Chlorine addition also not there. Hydrogenation means hydrogen addition is not there. Dehydrohalogenation means hydrogen and halogen is going out from the main structure. That is called as a dehydrohalogenation reaction. That's why this is a which reaction? This is a dehydrohalogenation reaction. That's why these reactions, if you look at, this is nothing but your dehydrohalogenation reactions. Is it clear to everybody? So this is a which reaction? Dehydrohalogenation reactions. Now if you look at the 52 questions, among the following, the intensive properties are in for independent of mass, in for independent of mass, independent of mass. Mass independent properties is called as a intensive property, or the ratio of two extensive property is nothing but a intensive property, and mass dependent property is a extensive properties. So now temperature independent of mass, that's why intensive property. Pressure means what? Force per unit area, my dear. Pressure means force per unit area. Force and area. Force is a depend on mass. Everybody knows the Newton's second law. So force will depend on mass. Area also will depend on mass. If mass increases, area increases. If mass increases, force also will be increases. Now this is extensive property. Force is an extensive property, mass dependent property. Area is also extensive property, mass dependent by mass dependent, which make the mass independent. That's why the ratio of two extensive property is nothing but a intensive properties. So that's why temperature is an intensive property. Pressure is also intensive property. But volume is related to what? Size. So that's why if my mass is more, size will be more, volume will be more. So that's why it depends on mass. Heat capacity. Heat capacity means the amount of heat required to increase the 1 degree centigrade temperature of the substance is a heat capacity. If my 4 gram substance is there, whatever amount of heat required to increase the 1 degree centigrade temperature, but wherever I have a 4000 gram of substance is there, in 1 degree centigrade increment of temperature, requirement heat will be what? More. That's why heat capacity is a mass dependent property or extensive property. That's why volume also mass dependent, extensive property. Heat capacity mass dependent, extensive property. But molar heat capacity is an intensive property. Why? Because molar heat capacity means heat capacity of a 1 mole of substance. When I am fixing the mass of the substance, so that's why it will be independent of mass. That's why heat capacity is an extensive property, but molar heat capacity is a intensive property. So that's why here option 3 and option 4 are extensive, whereas temperature is intensive and pressure is also intensive, as it's the ratio of the two extensive properties. The ratio of two extensive properties is nothing but a intensive property. Now we look at the options. First option is there 1 and 2, second option 1, 2, 3. 3 cannot be intensive. Third option 1 and 5, fifth 1 and 5, fifth option itself is not there, and 5 only, that option also not there. So temperature and pressure are intensive property. That's why first option is there 1 and 2, that means temperature and pressure are intensive property, that means independent of mass. That's why which options will be your answer? First options will be your answer. Is it clear, everyone? Now let us look for the next questions. In next questions, there is a one column matching question was there. In that questions, what they are giving? Match the column 1 with column 2. In the column 1, what they are giving? Hund's rule is A, Aufbau principle is B, Pauli exclusion is C, Heisenberg uncertainty principle is D. Whereas in column 2, P, Q, R, S they are written, and there are some content they are written. In the P, they are telling no two electron in an atom can have the same set of 4 quantum number, which is nothing but everybody directly based on the Pauli exclusion principle. No two electron can have the same 4 quantum number. In Q, they are telling in ground state the orbital are filled. In ground state of element of atom, orbital are filled of their increasing energy. That means lower energy orbital first and then only higher energy orbital. So it is nothing but a which principle? Aufbau principle. Whereas in the R, they are telling pairing of electron in the orbital belonging to the same subcell does not take the place until each orbital is singly occupied. That means Hund's rule of maximum multiplicity, what is telling? It is telling like that whenever equal energy orbital is there, then electron will fill it up first, 1, 1, 1 with the same parallel spin, then only pairing will appear. It is nothing but a Hund's rule of maximum multiplicity. Is what is telling it is impossible to determine the exact position and exact momentum of a subatomic particle simultaneously, which is nothing but a Heisenberg uncertainty principle directly from NCERT line. So that's why now we have to match. If you match Hund's rule, which is Hund's rule? Hund's rule is telling pairing of electron in the orbital belong to the same subcell does not take place until and unless orbital is singly occupied. Each orbital will first 1, 1, 1, then only pairing. It's nothing but a Hund's rule of maximum multiplicity. That's why A will be connected with a which one? R. Now, Aufbau principle you look at. Aufbau principle is telling B is nothing but a Q, because in ground state, first electron will fill it up lower energy, then only higher energy. So that's why B will be nothing but a which one? Q. Now, Pauli exclusion principle, no two electron can have the same 4 quantum number. C will be matching with the P. So that's why C will be matching with your P. And then Heisenberg uncertainty principle, D will be matching with the S, so that it is impossible to determine. Now you check it. So your A is matching with a R. All options, all first 1, 2, 3, A is matching with a R. B is matching with a Q. B is matching with a Q, 2 and 3 is there. Okay. Then C is matching with a P. C is matching with a P, only third option is there, and D is matching with a S, also third option is there. That's why which options will be your answer? Third options will be your answer. Is it clear, everyone? Okay, let us go for the next questions. In the next questions, what is there? In the next questions, which molecule ion out of the following does not contain the unpaired electron? Does not contain. You can do these things very easy manner. If you know one trick, logical, you can do by normal way as well as logical method. Suppose if you look at, I am telling you that idea in molecular orbital theory idea. If I am saying you, if you look at in molecular orbital theory, up to 14 electron, electron filling order. What will be their electron filling order? Up to 14 electron. That order is, I hope everybody you know, two atomic orbital will combine. They will form a two molecular orbital, one with a lower energy, bonding molecular orbital, one with a higher energy, anti-bonding molecular orbital. Electron will enter to the bonding molecular orbital, will get stability. And when electron enter to the antibonding, electron, that molecule will get instability. So then sigma 1s like that. After that, sigma 1s star. Then you will have a sigma 2s, and then here it should have a sigma 2s star. It should have a sigma 2s star, and next one is sigma 2pz, because 1 is atomic orbital, 2s, and then 2p y, x and z. X and y generally used to form a pi orbital, and z used to form a sigma bond, pz orbital, and px and py used to form a pi bond. Why? Because it's a convention, z axis is a molecular axis. So that's why sigma 2pz is not over here. Then what is happening over here? You look at, here is their pi 2px, and they have a same with a pi 2py, and then only here sigma 2pz, and then only you have a pi 2px star equals to pi 2py star, which is lesser than sigma 2pz star. This is the up to 14 electron order. Now after 14 electron, what will happen? Sigma 2pz will be over here close to the sigma 2s star. Why? Because up to 14 electron there will be sp mixing occur. Due to sp mixing, their gap will be increases. You know, when the two molecular atomic orbital combine, molecular orbital form like this, they are atomic orbital, this side energy, and here this is your bonding molecular orbital, and this is your anti-bonding molecular orbital. Anti-bonding molecular orbital denoted by star. This is the idea. So that is why if you look at over here, whenever sp mixing is there, up to 14 electron order, whatever the species will be there will be a sp mixing. That's why sigma 2a star, sigma 2pz, they are away to each other. You look at when they are molecular orbital gap is increases. So that's why here the gap will be there. You look at gap will be there. Gap is increases. Now every molecular orbital contain 2 electron. All rule, Hund's rule of maximum multiplicity, Pauli exclusion principle, above principle, all will be followed. And equal energy orbital, first one, then pairing, same way like a atomic orbital filling order. Then you fill it up. Suppose here N2, nitrogen 14 electron, how you will put? 2, 2, 2, 6, 8, 8, here 2, 10, 12, like this, 12. And here this is nitrogen. If you look at nitrogen bond order, nitrogen molecule, you know what is bond order? Bond order is nothing but a number of bond present between the bonded two atoms is a bond order. Bond order as per molecular orbital theory, number of bonding electron minus number of antibonding electron divided by 2. Bonding electron, how many is there? You look at 2, 2, 4, and here 6, 10. 10 minus 4. So 10 minus 4 means antibonding electron 4, bonding electron 10. That means 10 minus 4 divided by 2. That means 6 divided by 2, which is 3. As per the logic also is coming 3, and also we know this is the structure of nitrogen. In between there are 3 bond is there. That is also coming. So that's why this is the nitrogen filling order. So then only this way you can do. If you do all those molecule, you can do like this. Only what is the point you need to remember, after 14 electron, this sigma 2 pz only will be close to the sigma 2a star. Otherwise, that up to 14 electron, this is the filling order. What are the species they are giving, you have to follow. Otherwise, you can do one sort. What if there is a unpaired number of species have a odd number of electron? By default it will be a paramagnetic, or it will have a one unpaired electron. Only the even number of electron which has an unpaired electron, that is nothing but a which substance? 10 electronic species that have a unpaired electron or paramagnetic. That means which has an unpaired electron, that is a paramagnetic, which has a paired electron, that is a diamagnetic. They will not influenced by the external magnetic field. 10 electron also unpaired electron will be there, and 16 electron system unpaired electron will be there. These two exception only you have to remember. Otherwise, any even electronic species, always they have a paired electron, no unpaired electron. Only 10 and 16 even number of electron species have a unpaired electron. And obviously odd number of electron means definitely one unpaired electron will be there, because every orbital has to, molecular orbital has to fill it up by 2 electron. Odd number of electron means by default one electron will be unpaired. So that's why if I apply that logic rather than going with this your grammatical approach, N2 plus means 13 electron. N2 plus means 13 electronic species. N2 plus means how many electronic species? You look at N2 plus means here 13 electronic species, because nitrogen 14 electron. O2 means 16 electronic species. Okay now? And O2 2 minus means 18 electronic species. And B2 means 10 electronic species. Boron is 5 into 2 10. Oxygen is 8 into 2 16. 2 minus means extra 2, 18 electron. Now if you look at over here itself, they are asking which molecule ion out of the following does not contain unpaired electrons. So does not contain unpaired electron. So here unpaired 13 electron means unpaired electron is there. 16 electron means I told exception, unpaired electron is there. 10 electron means unpaired electron is there. So now only 18 electron is there where there is a no unpaired electron. Here 13 electron means unpaired, I am writing U. 16 electron means U, unpaired electron is there. 10 electron means unpaired electron is there. But 18 electron means paired electron is there. P I am writing. That's why which options will be your answer? Third options will be your answer. Which molecule or ion does not contain unpaired electron? Your answer will be the third options. Look for the 56 questions. You look at, this is a one complex salt they are giving, and this is your cation, simple cation, and complex anion. This is a complex anion, simple cation and complex anion. And now you look at, in complex anion, whatever the metal ion will be there, that will be like a always 8 you have to add, like a ferrate, aluminate, argentate, like that you need to add with their oxidation number in the Roman, and it's a oxalate ligand is there, which is nothing but a oxalate is nothing but a bidentate ligand as well as chelating ligand. So now aluminium here overall plus 3 charge is there. Okay now, that's why aluminium is plus 3. Each oxalate is carrying minus 2, then minus 2 into 3, overall charge is minus 6 and plus 3. Here the complex anion overall charge is a minus 3, that's why potassium is plus 1 into plus 3. That's why overall is a neutral. So that's why it's a complex anion, simple cation, complex. Then the name will be what? First there will be cation name, and then there will be anion name. Like any salt, sodium chloride, NaCl. First cation name, then anion name. But here anion itself is a complex. That's why potassium will be there. And then 3 is there. So that's why trioxalato, potassium trioxalato, and in a anionic part central metal atom of the complex is there. That's why 8th will be add aluminate. Oxidation number is 3. That's why potassium trioxalato aluminate 3. That's why which options will be the answer? Second options will be the answer for these questions. Is it clear? Then you look at for the next questions. In the next questions, what is there? Here they are asking the tendency of electron to lose electron, tendency of an electrode to lose electron is known as, very simple, loss of electron is a oxidations, gain of electron is a reduction, ability to lose the electron or ability to snatch the electron. Oxidizing power means what? Ability to snatch the electron, oxidizing power. And reducing power means ability to supply the electron. So oxidizing power means itself will go for a reduction, it will oxidize other. That's why oxidizing power means ability to snatch the electron. Reducing power means itself will go for oxidation, it will reduce other. So then reducing power means ability to supply the electron, whereas oxidation process means loss of electron, reduction process means gain of electron. But here they are telling in tendency of electrode to lose electrons, like if you take any galvanic cell, like here is like this situation is there, like this, A plus 2 double dagger means salt beach, and B plus 2 and converting to B. How we need to write? Left to right. A is converting to A plus 2. Here B plus 2 is converting to B. That means this is your oxidation half, this is your reduction half, connected by salt beach. So that's why here this is the oxidation half is anode, electrode anode, and reduction half is nothing but a cathode. Now tendency of electrode to lose electron, here what is happening? Loss of electrons happening, because A is converting to A plus 2 by loss of 2 electrons. So it is acting as a anode in a galvanic cell, and then here loss of electron is happening, and because of that their potential will develop, charge difference will be there. In galvanic cell mechanism it is there. So that's why it is a which reaction? Oxidation reaction, and because of that potential will develop. That potential is called as a what? Oxidation potential. So that's why tendency of electrode to lose electron is known as oxidation potential. Actually loss of electron by electrode is a oxidation process. Because of the oxidation process, charge difference will be there. Like that situation, suppose if you have a metal A and it is dipped into a certain salt of metal, so this is a A, from this is connected, this from here, this is coming as a ion into the solution by loss of 2 electron, and this electron is going out, keeping the electrode into the rod. So that's why in the solution will be more and more plus, and electrode will be there more and more reach of electron. So then solution is plus, electrode is a negative. There will be a charge difference between the electrode and the solution. When there is a charge difference is there, potential is developed. That potential is called as a oxidation potential. So that's why here the reaction is there, oxidation, loss of electron. Because of that charge difference is there, and because of that potential is developed. That's why the tendency of electrode to lose electrons is known as a oxidation, and because of that what potential will develop? That potential is called as a oxidation potential. That's why which options will be the answer? Third options will be the answer. I hope everybody understood all questions clearly. To get more this type of question answer discussions, come and have a look my channel, comments and subscribes, and get more and more question answer discussion, and be confident for your upcoming JEE and Neet exam. Thank you very much. Thank you all.